These are my mountain bike ride times, not Shane's from the Share Your Work. So this is a different set of distances and times. Notice at the bottom it says Gary's rides. So another note for you Google Sheet users out there, if you want to share a file with somebody, you have to make sure the share settings are correct. And if you have an institutional Google account, like a Google account through BMCC or EOU or some other school, when you first go to share a document, it's restricted. Okay, and so if you copy link and send anyone that link, they're not going to be able to use it because it says it's restricted. So I would have to change that. Now it says people at BMCC can see it, but most of you don't have a BMCC Google account, so that won't work either. I have to have anyone with a link. So if you're a Google user and you have a spreadsheet you want to share with me, you've got to make sure that when you get that link, it says anyone with the link can view it. Super important. So I copied that link. If anybody wants to play with this in a spreadsheet with me, I'm going to put this in the chat. So you can just click the link in the chat and that'll let you open this file here. So what I'm going to try and do is I'm going to graph these by hand and decide which 2 points I'm going to use to make this happen. Now these distances and times here are in the order that I did the ride. So maybe this one over here is back from August and this one is in, beginning of September, mid-September, later September, and these are like beginning of October rides, right? They're not in any particular order that's meaningful for us, but that doesn't matter. The bottom line is it took me an hour and a third to bike almost 11 miles. So I do a lot of hilly mountain bike rides. It's rather slow going uphill. So I'm going to try and make a graph of this. So to do that, I need to plot these points. So feel free to play along and let's put that on a new page. So a spreadsheet is an option. You don't have to graph by hand. Spreadsheets do great graphs. So I'm going to graph it by hand though. So I need a y-axis, let's put that over here, and I need an x-axis, and I get to decide how I'm going to scale my axes to plot these points. It doesn't always make sense to do something like go 0 to 10 because your numbers don't reflect that. So some things to note about this table up here, the smallest number I see is the 0.71, so that would be, oops, the minimum number in the times, and the largest time is what? I think it's the 1 hour and a third. Okay, so that's the max for the times. So when I'm scaling my x-axis here, I got to get myself from 0.7-ish all the way up to 1.33. So there, I don't even need to see 0 for time. So what I'm going to do is just make a little squiggly mark here. I'm not starting at 0. I'm just going to start over here at, say, 0.7. And I think I have enough room to make every other one. So this right there would be 0.8. And every other, this would be 0.9. Every other 1.0. 1.1, 1.2, 1.3, this would be 1.4 over there. So you got to kind of play around and figure out a scale that's going to work for your numbers. So that's my scale for the time in hours. I have to do a similar thing for the miles. So what's the smallest distance? So it looks like it is this one here. That seems to be the min for miles. That's about 11. This one right here is the max. So I got to get from a little over 5, almost 6, to up to 12. So maybe I'll go from like 5 to 13. So I'm not going to start at 0. I'm going to put a little broke. That's a little squiggle to say a break in the axis. And I'm going to say this is 5 right here. And then I think I can go 6, 7, 8, 9, 10, 11, 12 would be up here, and that's just over my largest number there. So that would be the scale on that axis. And every situation is different. You got to mess around. Often I make mistakes and I scribble it out and try again. All right, and then I do my best to plot the points, like 1.33 for time. That's 1.3, that's 1.4, 1.35 would be in the middle. 1.33 I'm guessing is about right here-ish. And then 10.97 is almost 11. So that's going to be somewhere up here. I think right there. And so for each point, do your best to estimate it. This one's a little under 1, which is right there. And then 8.29. So that's 8, that's 1, a little under 1, a little over 8. So maybe it's about right there. And I already previewed these. So I'm going to back up to show that because this is kind of long and tedious. After plotting all those points, it is going to look, if I did a good job, something like that right there. Okay, so that would be my points. Once I have the points, like I can't just look at the table and pick any 2 points, because suppose I accidentally or on purpose picked these 2 points right here, right? Is that a good line for these points? Whoa, that's horrible, right? That's not a good one, right? So you can't just randomly pick 2 points. You got to look at this and say, I like these 2. Okay, so that would be bad, but maybe good would be like this point to that one. That might be a little too steep. The line doesn't have to actually go through the points, right? You could pick a line that does something slightly different. Maybe those 2 points right there. So you have to make a choice about which 2 points you're going to use. So maybe here I might use whatever that point is there. Oops, highlighter. That point is there, and whatever that point is there. So I'm going to go back to these other ones for a sec. So either you have to graph these on a piece of paper neatly, graph paper would be good, or if you don't have graph paper, you could do it in a spreadsheet. So I'm going to show the spreadsheet version next, and then we'll find an equation, and then we'll get to work on our other stuff. So I shared this in the chat. Click the link for it. If you're watching this in the future, I'll put that link in the description of the video. To have the computer graph these, you just highlight the data, and then either find the Insert Chart button or go to the Insert menu and then choose Chart. If you're an Excel user, it works a little bit different, but it's similar. So the computer guessed at a scatter plot for me. If it didn't guess right, then under Chart Type, you can scroll down until you get the scatter plot. It put my labels in there for me, which is kind of nice. The title at the top kind of sucks, but we'll just go with it. So then I would just kind of hold a piece of paper up to my screen to try and pick 2 points here. So I'm going to do that here. Okay. Yes. Okay. So I think looking at this, and in my paper version would look similar to this once I was done with it. This point right here, and maybe that point right there looks good. So let's close the editor so I can see which points they are. This one is the 6.81. So that would be this one right here. So that point looked good to me right there. And then this one looked good. And that's the 9.76. So this one looks good to me. So let's highlight that one. So I would use those 2 points. Would other points be okay? Like maybe that one up there, this one over here. Maybe you'd have to draw this and see if the line you draw looked good for the other points. So that's one reason you want to get this on paper. If it's bothering you that you can't see all of that point up there, these graphs are editable. So I can click and edit the chart. It's a little harder to edit in Microsoft Excel. In Google Sheets, I just go to Customize. And in this case, I want to be able to see up higher, so that point's not cut in half. So that would be the vertical axis. And the hard part is figuring out which menu to look at. And I just need a bigger max than 12, so that's not cut off. So maybe I could set the max to 13, and now I can see that point up there. Okay, so that looks a little better. So again, I'm picking this second point on the graph. Now these numbers aren't in order, so it's not the second point in the table. Keep that in mind, super important. And then I pick this, which is what, the 5th point on the graph, which ends up being the second to the last point in the table. So I had to know which point is which when I pick them. All right, so I'm going to find the equation for the line through those 2 points. I'm going to go back to my notebook to do that. So we need a screenshot. So back there, and oh, no, I don't need a screenshot. I just need my notebook. All right, so I decided again on highlighter, this point right here and this point right there. Check, I did that right. Oops, where'd you go, spreadsheet? So as usual with many other problems we've done, the first step is to find the slope. And so my slope here is going to be the difference in the y values. So I would say 9.76 minus 6.81 divided by the difference in the x values over here. And that would be 1.09 minus 0.78. And usually I calculate this in one shot on my calculator by just putting them in parentheses when I calculate that. So let's see how I do here. Calculator out. And I could use my spreadsheet as a calculator, but many of you don't, so I'm just going to use Google as a calculator. So I want parentheses 9.76 minus 6.81, close parentheses, divide by the 1.09 minus the 0.78, close parentheses, and Google says the slope is about 9.516 if I went 3 decimal places. Let's double check that in the spreadsheet that I did it right. In the spreadsheet, if I wanted to do the slope, let's call it M, I could do a similar thing, equals parentheses, take this y value minus the other, and the minus is just the dash on the keyboard, close the numerator, divide that x value minus the, oops, I forgot my parentheses for the denominator, that would be tragic. So the numerator and denominator need parentheses because they're complicated. And I get that same number, 9.516-ish. All right, so I have a slope. So back to the drawing board. So this is wavy equals approximately 9.516. And by the way, what does that number mean? Interpretation of that? These top numbers are miles. These bottom numbers are hours. So I just took miles divided by hour. So that would be my miles per hour. So this is an estimate of my average speed. On average, when I'm mountain biking, I'm doing about 9.5 miles per hour. Okay. To get the whole equation for the line, y equals mx plus b, I have to then pick one of my points to plug in for x and y along with the slope I just calculated, and then I can find b. So maybe I'm going to pick this first point here, the 0.78. So the y value there is the 6.81, and then 9.516 times the x value, 0.78, plus b. So I have to carry out this multiplication and then subtract it to the other side. So I can do that in my calculator. And let's see if I did a good job. So let's use the spreadsheet as a calculator again. B equals, so let's see, I had the 6.81, so equals that guy. And then I have to subtract 9.516, my rounded slope is what I'm using here. I could use the exact number above, that would be a little bit different, times my x value. So my calculator says that number is negative 0.612 roughly to 3 decimal places. Negative 612. So I think that B is about negative 0.612. So then if y is my distance and x is my time in hours, then I think the equation is y equals, let's see, where'd that go? 9.516 for a slope times x minus 0.612. So I know what the slope means, that's miles per hour. What does the y-intercept mean? Let's see, that's usually like a starting point. It's a y value, so it's miles, negative 0.6 miles. So it turns out it does, in this case, the y-intercept doesn't have a reasonable meaning. It's just needed to adjust the line so it flows through the points in the right way. So I'm just going to take a quick look at that in my graph on the computer. I can have the computer draw that in. Let's see, where'd that one go? There we are. So to draw that line in here on the computer, that's a little bit trickier. I'm going to have to sneak it in. And if you want to know more about this, I can show you later. This is my model. And then I'm just going to say equals 9.516 times time plus that negative number, so minus 0.612. So these are numbers from the model equation. They don't quite match the actual points. And so now I want to try and do a graph of all these together and see what happens. Oops, wrong button. Insert chart. And I think I missed a point there. So let's go through C8. And I'm just going to tweak this a little bit by making the red one as a line. All right, so let's close that. So zoom out just a little bit. Okay, so this is the line I guessed at. I hit 1, 2 of the points. They're hidden under those red dots. And that's not too bad. I did all right. Okay. So alternatively, I would have that all written on my paper and done with a regular calculator is the other way to go about that. So let's see, where are we at here? Let's get back our home screen. Is that this one over here? Things that have to get done. Finish up any homework that you're not done with. We have lesson 3.7 to work with. So that needs to get done today or by tomorrow. Good idea to get it done today. And then homework for 3.7 is due, it looks like Friday. And then the share your work in the learning forum is due by Saturday. So let's stop this recording.